Equations predict the character of physical systems. It is not every equation that does that, but majority of mathematical equations predict the character of physical systems. All of us alive like it when we can tell what a particular physical system will do under a particular condition. We use numbers to predict the characters of such physical systems. There are numerous physical systems in this world. Mathematically, we use numbers to tell the character of a physical system under a certain condition. Therefore, equations are instruments of prediction regarding the characters of physical systems. You may ask, if that is true, how then do equations emerge? How do they come to be? One way equations come to be is by graphing, use of graphs. Second method, among others, through which equations come to exist is by tabular hypothesis. Whether it is by graphing or by tabular hypothesis, that is one thing that stands out that must be done before any of them is adopted. And what is that? First, a table is developed. A table of values gotten from real-life experiment, a scientific process of testing and observation carried out on that physical system. If the table developed is easy enough to be handled by hypothesis, that method is just adopted. But if the table created from real-life testing and observation is not easy enough to be handled by hypothesis, the next method is just graphing. On that note, I say welcome to the world of graphs and equations. Equations that help us predict the character of a physical system. Please find the content of this work. In it, you will find very interesting items, interesting sections that will help you just learn how to use graphs to create mathematical equations that enable you predict the character of physical systems under certain conditions. Let us take the first shot, that is developing equations by tabular hypothesis, and that is our first lesson objective. Please watch what follows.
Again, look at this table closely and compare it with this equation. It says D is equal to 2V. This is equation gotten from this table, where D stands for the distance traveled in kilometers and V stands for the volume of the petrol or any type of fuel used for the vehicle. If D stands for distance traveled and V stands for the volume of the fuel, let's find out if D is equal to 2V is actually the formula or the equation connecting the distance and the volume of fuel used. How? Let's look at this table. When the volume is 2 liters, put the V here. That is, place this 2 here. And what do you get? 2 times 2. Because 2V means 2 times V. It doesn't mean 2 plus V. So whatever you place here, you are multiplying it with these 2. Therefore, if you place these 2 here, the distance will be equal to 2 times 2. That gives us 4. What if the volume is now 4 liters. Place it here still. And what do you get? The distance will equal to 2 times 4. That is this 8. What if the volume is 6? Place the volume here. The distance you're going to get is 2 times 6. That is 12. If the volume is 8 liters, the distance you're going to get will be D is equal to 2 times 8. And that will give us 16 kilometers. What if the volume is 10 liters of fuel? Place 10 here as usual. To get the distance, multiply 2 by 10. 2 times 10 is this 20. Therefore, this is equation summarizing how that vehicle behaves. Don't forget that we did not know this one before. It came to be after we saw a table that came from the experiment. Now, let's turn our attention to what happens to the distance traveled with other volumes of petrol, and what also happens when we have determined the distance we want to travel, so that the next thing to do is determine how much petrol we need. Let's see. Let's say, for instance, we have a journey of 36 kilometers to make. The owner of the vehicle has a journey to make, and that journey will be of a distance of 36 kilometers. The next thing he has to do is to find out the approximate volume of petrol needed for that journey. Students, what will you do if you were in his shoes? If you were the one that has the challenge of knowing how much petrol you're going to put so that you can make a journey of 36 kilometers, what will you do? Please, if you go back to that same formula, D is equal to 2V. All we need to do is to replace that D with 36. See it here. D used to be here, as you saw a short while ago. But now, since the distance the man is traveling is 36 kilometers, we have replaced that D with 36, so that it now reads 36 is equal to 2V. Or, as beginners, we wish that this 2V carrying the unknown is on the left-hand side. When that is done, we have 2V is equal to 36. Don't forget why we're doing this. We want to help the man know the approximate volume of petrol needed for his journey. Let's continue. Now, 2V is equal to 36 is an equation having just one unknown. Let's try and solve it. As before, 2V over 2 is equal to 36 over 2. It is believed you know what happened here. When that is done, the result says that V is equal to 18 liters. What it means is that the owner of that vehicle will need 18 liters of petrol to make a journey of 36 kilometers.